Hi. A lot of times when companies come to me with CAPA issues, usually the issue is that they're not trained on the CAPA process or they don't have an adequate form for a CAPA. But this week, I actually had a client come to me with a CAPA issue, and there was nothing wrong with their form. There was nothing wrong with their procedure. If anything, I think they actually did a little bit too much. So I'm going to share some of the details of this. I can't share any of the proprietary information or identify the company, but the example that I will give will be generic enough that I think it can apply to a lot of companies and you can learn something from it. So the situation starts like this. The company noticed as they were doing final inspection that there was contamination on the product. And in this particular case, it was lint. It was identified as lint was remaining on the product. And that wasn't something that they saw before. So they identified the product as non-conforming material, quarantined it, and opened up a CAPA to determine what is the reason why we have this lint on the product. So far, everything's been done exactly the way you should do it. You have an inspection process. Somebody identifies something that's non-conforming, and you put the product on hold. You write it up as a non-conforming material report, and then you open up a CAPA to investigate what is the reason why we have this contamination. The ultimate determination as part of their investigation was that the problem was they made a change in the way they were cleaning product. They switched from one cleaning method to a manual cleaning method using a new um, disinfectant wipe for the product. Is there anything wrong with this? Not necessarily. There's a lot of companies that use manual processes for cleaning parts prior to sterilization and packaging. There's companies that use automated methods, they use manual methods. There isn't a right or a wrong way. So, how would this problem have occurred in the first place? Because it's not just an issue of, oh, they used the wrong cleaning method. This cleaning method could be used just like any other cleaning method. But why did this result in lint? And why didn't they catch it before it found its way into normal production? So there are two typical tools that you would use in this situation. The first tool that a lot of people try to use is a 5 why analysis. Now, one of the things you need to remember is that you don't always have to ask why 5 times, and sometimes 5 times isn't enough. But in this particular case, if I were going to use a 5 why analysis, my first question would be, why do we have contamination on the product? And the answer would be because we had a change in the cleaning process of the parts, and the cleaning process wasn't validated to make sure that there was no contamination left behind. The second question would be, why was the cleaning process changed without revalidation? And the answer to that question would be the person that authorized the change didn't recognize that this was something that required revalidation. So it's a process change. They didn't realize this is something we need to validate before we make this change. So why did this person make this change without realizing you need to revalidate it? The answer to that would be the person wasn't adequately trained on change control. So we've only asked 3 whys here, but we've come to the root cause. The problem wasn't that they don't have a change control process. They did. The problem wasn't they didn't have adequate inspection. That's how they caught the problem in the first place. It isn't necessarily that a manual cleaning process is bad. There are lots of companies that use manual cleaning. The issue was that they made a change and they didn't validate that that change wouldn't cause an unintended consequence. And if they had validated the manufacturing change process ahead of time, they would have caught this before it went into normal production. So that's the root cause. The person didn't realize that they needed to do a validation of this to catch any unintended consequences of the process change. You could keep on asking why, but as I've said before, with CAPAs, you tend to, if you dig deep enough, you come up with one of 4 problems. Either You don't have adequate procedures, but they did have a procedure. The person didn't follow it. So that wasn't the issue. You could say that the issue is inadequate resources, but there was a person that approved this, so it's unlikely that that's the issue. It's a step before approval should have occurred, the validation, and that didn't occur. Does the company not have sufficient resources to validate a process change? I'm not sure. We could go deeper into that, but I think the more likely scenario is that the person wasn't adequately trained on the need to revalidate any process changes. People are very good at picking out design changes. So they change the material, they change what it's made out of, they change the sterilization method. They identify those as design changes. But when they make a manufacturing process change on something as simple as cleaning a part, they may not recognize that as, oh, that's a design change too. And I need to validate that change and make sure it won't have any unintended consequences. The fourth reason that I sometimes see for a root cause is that there isn't adequate management oversight. So it's possible that somebody's identifying, hey, I'm making a process change here. What do we need to do about it? And nobody in management's paying attention and they're just making the changes. But in this particular case, I think the issue is most likely the person that authorized the change didn't realize that before they make the process change, they need to validate the cleaning process that's manual to make sure it won't have any unintended consequences. So that's how I would do a 5 why analysis. And the root cause I would come up with was inadequate training on change control process. Now, there's another tool that we could also use, and that's actually the process the company actually chose in this case. They did a what we call, some people call it a 6M diagram, some people call it a cause and effect, an Ishikawa diagram, a fishbone diagram. But it has 6 different parts to it. If you play around with the selection of words, you can have them all begin with M. But one of them is the people that are involved in the process. To make it begin with an M, a lot of people will use the word manpower. Not very politically correct, but the idea is this is a people issue. Did it only occur on first shift? Did it only occur on second shift? Did it only occur on third shift? In this case, it occurred on all products where they were manually wiping the process. It didn't matter who did it. So that wasn't the issue. Another possibility would be measurement. Is this a measurement method? But this wasn't a measurement method. It isn't, were we measuring, is it the right dimension? It wasn't out of dimension. It was a cleanliness issue. So that's not the issue. We didn't change the materials of the device, but we did change the process. The environment where we still clean the process hasn't changed. Where we make it the process or product, that hasn't changed. So it's not an environmental issue. Some people will call that Mother Nature, to have it begin with M. Another possibility is machine, but in this case, it was an automated process. And for simplicity, they tried to switch it to a manual process. And part of that had to do with the machine broke. So if you were trying to address the issue of, well, why did the machine break? That's a totally different issue. That's maintenance, having a standard preventive maintenance plan for the equipment, doing calibration, doing maintenance on the equipment, having a backup piece of equipment. Those are things we could get into. But in this situation, what they did is they switched from a machine process to a manual process, and they didn't revalidate it. And so everything points to the issue here is the method of cleaning. It went from an automated process with a machine that was working and leaving no debris behind. And now we have a manual process, we're leaving lint behind. And how, now that we know the process change is the issue, how could we have prevented this? Now, the correction is really simple. One possibility is you fix the automated cleaning machine and go back to an automated cleaning process. That would be a very simple solution as a correction and containment. So we contain all the product, put it on an NCR, we rework it. So we say all the product has lint on it. We're going to rework that, and we're going to take it through the automated cleaning process that we were using before. We'll re-inspect the product and make sure it doesn't have any lint, and then we're back in business. But if we want to figure out how to make this cleaning process work properly, that's a manual process, how could we do that correctly? Well, we can write up a validation plan and decide how we're going to determine whether the manual cleaning process is acceptable or not. And one of the things that you should be looking for whenever you have a manual cleaning process is there anything left behind on the product? Did you adequately clean it? So, is the bioburden low enough afterwards? Is the endotoxin low enough afterwards if it's going to be an implantable device? And third, is there anything left behind on the product that's visible in any way, shape, or form? And lint would be on that list. So you can check for the first one, the bioburden. You measure bioburden. So you would sample some parts for bioburden, send them out for testing, and measure that. And you would have it to have a baseline for what the normal bioburden was before we made this process change, and compare, does it fall in the same area of bioburden? Is it higher than normal? Is it lower than normal? Is it at the normal range? And if you don't have a lot of data previously on bioburden, it's going to be hard to determine, is it better, worse, or the same? But if you have enough data, you should be able to statistically analyze that and say it's in the normal range or it's better. And for something like bioburden, you typically only have a maximum that's an issue. So if it goes up, it's a problem. But if it stays the same or gets better, that's not a problem. So that's one thing you can look at. A second criteria for cleaning the parts would be endotoxin. This actually tends to be the toughest thing to look at whenever you're cleaning a part. Whenever you have an implant part, it's very easy to have endotoxin get up to a high enough level where it's a problem. For those of you that don't know what endotoxin is a part of bacteria or fungus or some sort of microbe that's left behind on a part after the microbe is killed. And if that residue of the microbe is left behind, it can result in septic shock. The body will have an immune response to those endotoxins, and you will have what some people will call sepsis or blood infection, and it can kill you. So if we have a problem with parts that have endotoxin on them, we put that in a person's body as an implant, they could die from septic shock. So one of the things they have is they have a USP standard. They also have an ISO standard for measuring endotoxin, and they have a limit for how low it can be for certain types of implants. And then for the most critical implants, ophthalmic implants, any implants for the to go in the brain or the central nervous system, those or the heart, those particular locations, they have a much lower limit for endotoxin. That's an order of magnitude or more below the normal limit. So, but you can measure that endotoxin limit and you can say, okay, this is well below that limit, or you can say, no, it's not low enough. We need to come up with a better cleaning process to remove the endotoxin, which means removing the bioburden that caused it. And then the last thing you would look at would be any kind of residues or contaminants that are left behind. Whenever we have a cleaning process, we want to look for those residues. So do we have any detergent that's left behind? Can you measure that detergent? Do we have any of the soil? So oftentimes when they're validating a cleaning process, they'll have a synthetic soil. Do you have any residue of that soil left behind? Things that we would look for would be markers such as carbohydrates, proteins, or if it's a blood contaminant, you'd be looking for hemoglobin. Those would be the typical markers that we would be looking for. Can you remove those adequately so they're not detected after the cleaning process? But you have to put some on the product beforehand, and usually we use synthetic soils to contaminate the part and then try to remove those synthetic soils so we can't detect it. And then the last thing you might look for would be something like total organic carbon, a TOC test. That's a very sensitive test looking for any kind of proteins left behind. Another thing you might look for is the actual disinfectant or detergent that you use for cleaning. That's a little difficult if you're using something like an alcohol. most of that evaporates, and it's a simple carbon-based compound. So it's a short chain of carbon and a little bit of oxygen and hydrogen. So your most likely test you're going to be able to do here would be something like total organic carbon. But if you use some sort of phosphate-based detergent, you can usually detect those detergents left behind, any residue of that detergent. And usually there's a molecule that you can detect if you send it off to a lab. So these are the things that you might set as criteria for acceptance on your validation. You might test bioburden, you might test endotoxin, you might detect any residual soils that are left behind that weren't cleaned off, and then any detergents that were not rinsed off after you finish cleaning. Those are the things that you would establish limits for and have a predefined acceptance criteria for pass-fail. So it must be below this limit for each of these things. Those are the things that somebody that is making a process change to a cleaning process should be aware of. So you could argue, number one, maybe the person that was doing this wasn't trained on cleaning validation. That could be the issue. Or the issue could be they weren't even aware that you needed to validate cleaning in the first place. So it's one of those two areas. This person made a change. There's nothing wrong with using a manual cleaning process, but it's how you make sure the manual cleaning process is adequate. You have to be aware of cleaning validation requirements, and there's standards for that, and there's testing for that. And you also have to be aware that validation is required for a change in a cleaning process. In this particular case, the company has a change control process, but the person making the change or people responsible, it might not have been just one person, didn't know that there is a process for cleaning validation. There are protocols for it. There are ISO standards and USP standards. There are acceptance criteria that you can set up ahead of time, and you have to do this prospectively. So before you authorize this change to this new process, you have to implement this. Now, let's say you had the situation like this company did where your machine is broken and you have to come up with something quickly. You can still validate the process before you release product. You say, okay, this next production run, we're going to use this new manual cleaning process, but we're going to purposely put all the product on hold until it passes the testing. So in this particular case, you're saying we're allowing a deviation. And the only reason why we're allowing the deviation is we're going to quarantine all the product that's made by this new process, and we're going to keep it as non-conforming product until we pass the validation. Once we pass the validation, now it's no longer a deviation because we've validated the process. We can approve it, and that is the new approved process for cleaning parts. But if you just make the change and you say, I think it'll be okay, that's not enough. You have to have a protocol ahead of time. You have to have predefined acceptance criteria. You have to do the testing, and you have to keep everything in quarantine until you pass the validation. That's the basic steps. When I said I think this company might have gone a little bit too far, the company also had in there documentation about not having sufficient people to do the work. That may be the case, but in this particular case, it's not clear that that would be an automatic leap from the documentation that I'm seeing. I'm seeing, yes, you might need more resources, but it's not obvious that that's what the issue is. What appears to be an obvious issue is the people that approved this change didn't consider the need to validate the manual cleaning process, didn't understand how to do cleaning validation, and didn't come up with a predefined acceptance criteria and put the material on hold before releasing it. They just made the change. And there wasn't any evidence that they even approved the process change. They just made it. So I didn't see this as obviously being a people resources issue. I saw this being more of a inadequate training or knowledge base for the people approving the change. And it really wasn't even documented. So this is a case where I would say the issue is inadequate training. and whether you did the 6M approach and you identify this as a process change that caused this, and why was the process change made without without catching this issue, it's because the people didn't understand the need to do process validation of a cleaning process. So, regardless of which tool you use, whether you use a 5 why analysis or a cause and effect diagram, I think you come to the same conclusion. A process change caused this, and people made the process change without validating it because they didn't know better. So, what would you do in this situation? As a corrective action plan, you would put all the product under quarantine that had contamination. You would rework it, and you would revalidate a cleaning process for this, and you would put everything on hold until it passed the validation. So whether it's a new wipe, a disinfectant wipe that doesn't leave behind lint, that could be a solution. Another possibility would be fix the old washer and go back to the old process. There are lots of things you could do, but it should be a team decision. In whatever decision is made, there should be some controls in place to prevent unexpected problems from occurring. So we don't know what will happen when we make this change to a new wipe. It could create a different problem, but let's learn from our mistakes and keep it all under quarantine until we pass the validation. And let's think of all the things we can test in the validation process and all the acceptance criteria we need before we release that product. So that's an example of how to do a corrective action root cause analysis and how to identify what things you should work on as a corrective action, what things you shouldn't. They identified how to quarantine the product, that's containment. They identified that they need to rework the process, so that's correction of it. But the preventing this from reoccurring, we need to train the people that are responsible that you can't just make a change to a cleaning process without validating it. So they need to be aware of the need to do cleaning validation and the consequences if they don't. So this is understanding the effects of defects in your work. So if you make a change and you don't know see the potential dangers of making this change without validating it properly, that can cause a lot of problems. And in this particular case, it was something we could catch, something we can see. But I could see more significant changes that could be made, such as a change in the design of the process. A change in the process for manufacturing that may not be visible at all. A good example of that is when a company switches from a machining process to a casting process. The casting materials, they can have voids left behind in it that make the product inherently weaker. The voids might not be detectable except with X-ray methods or dye penetration tests. Another problem that you could have with that is that cast materials are generally weaker than machine materials or forged materials. So you could have lots of problems occur switching from a machine process or forged process to a casting process for an implant. And a lot of them would never be detectable unless you knew better. So when you make a change to your manufacturing process, if you don't have people in the room that are saying yes to this, that understand all the risks of that process, you should be calling a timeout and say, we need somebody in the room that understands cleaning validation. We need somebody in the room that understands casting. We need somebody in the room that understands the differences and strengths of a part that's machined versus cast. Those are some of the things that should be involved in the decision-making process for this change. Is it okay or is it not okay? And if you rush the process and are in a hurry to sign off on and get moving ahead without making sure you have the right people in the room that really understand, then you could have a very big problem that could result in a very large recall or even deaths. So it's really important that we make sure whenever we make a change, whether it's a process change or a design change, we make sure the people approving it understand all the potential impacts of this change, and they are really knowledgeable about how to validate that change, whether it's a cleaning process, a manufacturing process, or it's the actual design of the product in terms of materials and labeling and dimensions for the new product. I hope that was helpful to you. As I promised, I didn't give any specific details of who this company was or what the products were that they were making. But I think it's a very useful example for companies out there thinking about making a very simple, innocuous change. You have to be aware of all the important factors of that process change you're making and understand what could be the potential impact so you can design a process validation properly. Um, Along with that would also be updating some of your documentation and risk management. Most companies will have a process risk analysis. If you change the process, you need to update that risk analysis, and along with that would be some additional risk controls associated with that, such as a process validation. That would be how you'd verify or validate that the process change and the risk controls are adequate. I hope that was helpful to everybody. If you have any further questions, don't hesitate to put comments below. And I'd love to hear what other kinds of problems you have with CAPA, and maybe we can include those in next week's session, our live streaming on Friday afternoons at 12:30 p.m. Talk to you later. Bye-bye.